the real number system. First of all, we need to identify the definition of an irrational number. An irrational number is a number that cannot be written as a fraction. So when we can write decimals as fractions that are terminating or repeating, then they are not considered irrational. But any decimal that cannot be written as a fraction is going to be considered an irrational number. So a decimal that goes on and on forever with no pattern that is repeating and it doesn't have a stopping spot, that becomes an irrational number. Some examples of that are pi, which is 3.14 is what we typically think of it as, but really that is a number that goes on and on and on forever. 3.14 is just our best guess as to what it's going to be able to plug it into a formula and solve it. And anything that is a square root of a non-perfect number, so the square root of 5 or negative square root of 92, those are all going to be irrational numbers. Only perfect squares, when we take the square root of those, are going to be rational. The next thing is identifying real numbers. Now, real numbers are what make up the rest of the numbers and irrational numbers. So everything that we can think of in terms of numbers at this point in time are considered real numbers. There is another category that we can call imaginary numbers that we won't get to until later in our math career. But right now, the numbers that we think of generally are real numbers. So those include rational numbers and irrational numbers, and we'll talk further about what a rational number is. Now, this is a diagram that shows the relationship among the real numbers. First, you talk about whole numbers. Whole numbers are any number that you typically think of as a whole number. 0, 1, 2, 3, all of our counting numbers, including 0. These are not negative numbers. They're all positive. They don't have fractions. They don't have decimals. They're just a whole number. Integers start including negatives. So they're whole numbers, but we include negatives. So -6, -3, the square root of 25, or even the negative square root of 25. Because the square root of 25 is 5, so -5 is still considered an integer. Some rational numbers are going to be those that are fractions already, like 1/4, 3/4, 2/5, 3/5, 3/8. Those are all rational numbers. Any repeating decimal, so 0.2 repeating, that 2 is just going to go on and on and on and on forever, because anything that is repeating like that can be turned into a fraction. Anything that has a terminating decimal, such as -7.5, the decimal stops after the 5, so it is a terminating decimal, so it's considered a rational number. And then again, irrational numbers are part of the real number system, but they're numbers that are not able to be turned into a fraction, like pi, square root of 5, and any decimal that goes on and on forever. It doesn't have a repeating pattern or exact stopping spot. If we're classifying numbers into those categories, for instance, if we're given the number 21/7, we first need to identify what that is. It's 3. So because it's 3, we identify it as both a rational number and a whole number. We'd have to classify it as both because it falls into both categories. If we are given the square root of 38, we don't need to solve it necessarily for anything, but if we did, it would be 6.164414, and it would just continue on. There's no pattern to it. And anytime you have a square root that is not a perfect square, it is going to be considered an irrational number. Now, if we have something like 0.2 and the 2 is repeating, that can be turned into a fraction, which is 2/9, because any number, you would just put it over 9 if it's a single number that's repeating. And although it's not a whole number or an integer, it is rational, so we would just classify it as rational. If you're given something like -2.5, it can be turned into a fraction. The example is -2.5. Do you have to? No, you can just identify it as a rational number. Now the square root of 100, if we do that, it's a perfect square. So because it's a perfect square, we get 10, which is a whole number. Whole numbers are also rational numbers, so we need to keep that in mind. We could even put that it's an integer there because it falls into that category. So it is not only a whole number and a rational number, it's also an integer. Now, if we are asked to replace the circle with a less than, greater than, or equal to sign, in this given example, 3 1/3 and the square root of 15. Well, 3 1/3 is 3.3 repeating, and the square root of 15 is 3.8729. So which one's greater? 3.8729. But we need to make sure that when we rewrite this, that we're putting 3 1/3 is less than the square root of 15, not their decimal equivalents. If we're asked to order our real numbers, so we're given 8 4/5, square root of 64, 8.3 repeating, and the square root of 76. If we look at this, 8 4/5 is equivalent to 8.8, square root of 64 is equivalent to 8, 8.3 repeating is 8.33333, the square root of 76 is 8.717797888. So if we put this in order from least to greatest, the square root of 64 would go first because it's 8. 8.3 repeating would go next because it's 8.33. The square root of 76 would be third, 8.71779788. And 8 4/5 would go next because it's 8.8. Notice we put them in order using the term that we were given, not the decimal equivalent. The next thing is solving equations. This is something we've done time and time again, but now we're dealing with squares and square roots. So a squared equals 36. We would have to take the square root of both sides. When we do that, when we take the square root of both sides and we're asked to find, what a squared is, we would do both the positive and negative, so the plus minus, because if we plugged in 6 for that, 6 times 6 is 36, but also negative 6 times negative 6 is 36. So the answer for this is negative 6 or positive 6. Another example, if we have 2n squared equals 170, the first thing we need to do is get the variable alone. When we get that variable alone, we would have to divide by 2 on both sides. And when we do that, we end up with n squared equals 85. Now we have to take the square root of both of those in order to figure out what n actually equals. And again, remember, when we do that, we have both the positive and the negative of whatever the number is. And since it's not a perfect square, we would estimate that it is approximately 9.2. So we would say positive 9.2 or negative 9.2.